everybody, it's Mrs. Peachy from your WCA physical science class, and I'm going to be doing a tutorial for you on our sound portfolio, which is in Unit 3, Lesson 5 of Semester 2. I just wanted to mention to you that I'm going to be doing an alternate sound unit or sound portfolio here. So it's not the one that is in the lesson, because the one in the lesson requires quite a few resources. So I know that not everybody's going to have those. I do, however, encourage you to do the one in the lesson because it's actually pretty cool. So if you have the materials found in the textbook, feel free to do that one and turn that one in instead. But if that is too inconvenient for you, or if you do not have those materials, then you need to make sure that you do this one instead. So anyway, making sure that my microphone is not muted, because I did do this recording already before with a muted microphone. So in any case, I think we're good to go. I'm going to have you look at my website first, because this is where you're going to find the information that you need for this alternate version. So if I click on the Physical Science B link and go down to where it says Sound Lab Sheet, that's what you're going to look at. Again, because this is a PDF, I encourage you to download this, save it to your desktop, rename it, and then open the saved version to use rather than using it straight from the internet. So here is my saved version. Trying to go through this a little bit quicker because last time I tried to do this too, I didn't get through the entire tutorial in the time that I have. So the first thing you're going to do is go to this first website, the BBC Schools website. We're going to click on this, and it's going to take you to this Changing Sounds website. You're going to be comparing some instruments, a guitar, a bottle, and a drum. And you're going to kind of do some things to them to change the amplitude of the waves and the frequency of the waves, and kind of see, what it sounds like and describe those changes. Remember that frequency changes pitch. Pitch means if a note is high or low, right? So high or low, that's pitch. Whereas amplitude is going to change volume. So whether you are loud or soft, that's amplitude. So don't get the two of them mixed up. I do oftentimes see people getting those mixed up. The last part of this, let's see if I can get here we go, the PDF back up, has some pictures here that you need to sort. You can type right in these boxes just the colors of the recorders, right? But when you're doing it on the website, you are going to be sorting them. So you're going to go to this link here that says Sort Sounds. You're going to click on it, and then you're going to be able to click and drag the recorders into the appropriate boxes. You're going to listen to the sounds they make, and you're going to order them by pitch and loudness. So as the highest pitched, loudest thing, like me, belongs in this box here, right? And the lowest pitched, quietest one belongs in this box. And it will, tell you if you've made mistakes and stuff like that as well. Once you're done with that section, you're going to go to section 2, which is where you're going to be testing some animals' hearing for sensitivity. So you go to this lab, and you're going to have certain animals, and you're going to see how their hearing compares to that of humans. You're going to test their high frequency and low frequency hearing. What's the range of hearing? And at which frequency is that animal most sensitive to sound? Okay? And you're going to gauge their sensitivity by their response. So, for example, I've done the bat for you already. Well, on the video clip I have anyways. So with the bat, if I click here, I can select any frequency, say 2000 hertz, and I can play the sound. And you'll notice that you don't hear anything. The bat is not making any sound. So we know the bat is not sensitive to that sound. Okay? Then if I select, for example, 12,000 hertz and play the sound, the bat has a response. So because I have already gone through all of these other ones here, I know that 12,000 hertz represents the low end, the low value of the bat's hearing sensitivity. Okay? So then I would continue to test the bat all the way up through here. I get to 45,000 hertz and I play the sound, and I notice the bat's wings are spread out farther. This tells me that this sound is more sensitive, or the bat is more sensitive to this sound. Okay? When I go to 70,000 hertz, I get the same response. So again, the bat is more sensitive to this frequency. And I continue to test upwards to the very top of the scale, where we still see that muted response from the bat. And I can even go at the 100,000 and see and yes, it's a muted response. So what that means is that I put the low end at 12,000, the high end at 120,000, and the most sensitive is going to be 45 to 70,000. Okay? So that's what you're going to be doing for the crocodile, dolphin, human, mouse, and snake. And what you're going to want to do is, look at what the responses are. Make sure you test every single frequency, okay? And some of these animals will not have an extreme range. Sometimes they will only be equally sensitive, at specific frequencies, but they don't have any one to which they respond more to. So that's okay. Just put none in there if that is the case. They should always have a low and high, however. Okay? When you're done figuring out the data table, you're going to answer these questions. Compare the ranges of sensitivity for each animal. How does the total range compare to the extreme range? Which animal species that you tested has a hearing that is most similar to humans and why? Which animal species that you tested has a hearing that is most different from humans and why? And it looks like I actually left out the box here accidentally for this one. So what you can do, guys, is you can actually go in and enter, say for example, you can add, I wonder if you can just, no. You can edit PDF, I think. Maybe. Oh no, you can go to comment. That's what it is. You go to comment right there, and then you can add a comment here that you can put your answer for that in the comments box, okay? Or what I've also had people do is just put their answer for question 3 in right after their answer for question 2 in the previous blank, because you can write what you want there, okay? It says here, analyze the hertz values within the total range of sensitivity and the extreme range of sensitivity for each animal. Explain why some animals are better adapted to hear particular frequencies than others. So what about a specific frequency would make that something the animal really is adapted well to hear? Okay? So for example, with the bat, maybe the really high frequency the bat can hear is like the frequency that the insect's wings tend to beat at the most. And so it's really, really tuning in to the same frequency as its food. That could be a reason why. So we got to think about what's going on in that particular animal's environment that would enable it or encourage it to really want to tune into specific frequencies. Okay, and then it says, what advantage does hearing give an animal in its environment? So think of many different advantages there, okay? Once you're done with this, just save it and attach it to the Dropbox, and that's all you need to do for this portfolio. So if you have any questions or concerns, you can contact me at extension 2204 or send me a webmail message. Have a great day, everybody.